Today, let's discuss oil analysis for engines and specifically on-site analysis solutions for engine applications. Let's talk a little bit about engines. What are we talking about? Well, we talk about engines in terms of RICE engines, what is also known as rotating internal combustion engines. There are two major types out there, spark ignition and compression ignition. For oil analysis purposes, we really care about the type of fuel that they are actually using to generate their energy. And you can kind of broadly define that as gasoline and natural gas style engines and diesel and heavy fuel oil engines. Why do we care? Well, 80% of the world's freight is still powered by diesel or HFO engines, and the vast majority of natural gas applications, pipeline environments still operate on natural gas and widely used. The vast majority of lubricants that are actually manufactured for the marketplace are either passenger car motor oils or diesel engine oils, and so they lead in terms of formulation development, and there's still millions of engines in operation worldwide performing critical functions. What do we care about in engine applications? Well, what's interesting about an engine is because of its compression cycle, you're always going to get some of the fuel that you are burning somehow getting into that crankcase, and so over time that's going to actually degrade the oil and then potentially damage the engine. So key points for engine oils is the oil will degrade over time and usage. Fuel dilution will occur. There's always fuel dilution getting in. A small amount, most of it gets boiled off, but if you get an excessive leak, you're going to have problems. Soot, acids from the nitrates and sulfate gases that are as a result of blow-by getting into the engine will increase in the oil and cause acid formation, which degrades the oil. You can get water contamination either by condensation or by the fuel, which contains water getting into the system, or by external ingression. You can have cylinder liner wear, connecting rod bearing wear, valve recession, coolant leaks. So a variety of things can show up in the oil and cause some problems. So as a result of that, we need to monitor oil. We monitor oil, and they're the most widely monitored application. Actually, most oil analysis when it first started was based on engine oil analysis, and it's still the largest component that's monitored worldwide. We do it for four major reasons. One is lube oil drain interval extension and to manage the oil better. We want to improve fuel efficiency and improve the green footprint on engines. If the engine is running well, it'll burn less fuel, it'll have less sooty deposits and poorer exhaust issues. We want to extend the TBO, or the time between overhaul. That's a metric for engine rebuilders and engine mechanics to manage. You want to push that out as long as possible. And of course, you also want to prevent critical failure. So the key tests that we care about, we always worry about viscosity. Why? Because it's the most important physical property of the lubricant. Multi-grade oils in engine applications need the result measured or tested out at 100 degrees C. We want to look at the TBN. It's a measure of the reserve alkalinity. We want to look at TAN for natural gas engines. We want to look at water. We want to look at fuel dilution. Those are key tests, but we also want to expand upon that. So if we summarize, what are the tests that you should be doing on site for various systems? For liquids fueled engines, that's gasoline, diesel, heavy fuel engines, you want to be running viscosity, base number, water content, infrared, oxidation, nitration, sulfation to look at the contaminants getting into the engine, elemental wear metals and additives and contaminants, soot content, fuel dilution, do a ferrous density for a screen, particle count is optional, and wear debris analysis is optional as well. For propane or natural gas style engines, LPG, again, viscosity, instead of TBN or in addition to TBN, do a total acid number. Do all of the tests that you also do for your liquid, although fuel dilution is optional in these cases because you don't expect to see a lot of fuel dilution in natural gas style engines. So with that, what are our solutions? Well, let's kind of break it up into the various applications, the major categories of where we see engines. So we see a huge amount of engines in mobile fleets. In those situations, you want a Microlab 30 or 40 solution is an ideal package. For stationary gen sets that might be used in industrial or natural gas compression lines, you can lead with the Minilab EL series or Microlab, either or depending on the use case. For OEM, R&D, engine development, Formula One support, NASCAR racing, you want to move towards a Minilab EL series because it's got the performance levels that they're looking for that type of research and development.